Hi, welcome to Trigonometries. Today we're going to do a little bit of a spreadsheet example that deals with population growth or compound interest. To start with, let's just talk about population growth. So here in the spreadsheet, in this first field that we're going to look at the initial population that we have. So say we have a population somewhere and it's going to grow over time. In the second column here, I'm going to put the growth rate. And let's just call it rate to make it simple. And then let's say it grows at a certain rate for a year, and what it produces is the current population. We'll put that here. The current population after a year of growth is going to be the initial population, which is an A2, plus the initial population times the growth rate, A2 times B2. Let's try this out for a single year. Let's say we start with 1,000 people. This growth rate is going to be a decimal value that we're going to convert into like a percentage. Let's put in something like 0.05, and we'll convert that value to a percent. So this is a 5% growth rate. And so that means that after 1 year, the population has grown by 5%, which is precisely what we found here. 5% of 1,000 is 50, and so the current population is now 1,050 at the end of the year. Now, if you take a look at this formula here, we can make this a little bit simpler by using a little bit of algebra. If you notice that the A2 is in both the first term here and the second term, what I can do is I can pull that out and produce instead A2 times 1 plus B2. And that's a little bit cleaner of a formula. All right, so this is the value at, say, year one. Now that's all well and good, which calculates the population after one iteration through the rate. But most of the time, we want to look at what's going to happen with the population over a much longer period of time than just a year. So we need to kind of cook this up a little bit more. So what I'm going to do, instead of having a current population column, I'm going to create a new column to the left here, and I'm going to call this year. The first year we'll list is actually year 0, so that our first row just represents sort of what we're starting with. And instead of using this current population formula, what we're going to do is on this field here is we're going to have it reference the value of the population one above it, so that'll be B2, times that 1 plus the growth rate, which now is at C2 because we added a column. And so this will produce that 1,050 that we saw from before. And that will be for year 1. In fact, if I put these guys together and I drag, it's going to try to follow this pattern of counting. So we're going to make all the years here out to year 15. And what we're going to do here for this guy is we're going to drag this one. It's going to copy this formula, but it's all relative. If I were to copy this down and drag and drop it, the B2 and the C2 would both be relative references. However, the rate's always going to be the same up here. So what I'm going to do is I'm going to turn the C2 reference into a static reference by putting a $sign on both the C and the 2 so that it always picks off C2 no matter what I do. Now when I drag and drop, this is going to make a copy, and the only reference that's going to be relative is the fact that it's referencing the population for the previous year and then multiplying by 1 plus the rate in order to get the population for the next year. And this will give us the population values all the way forward. Now if we're talking about a population, we will go ahead and mark this way and hit this button here to remove decimal places so that we get down to just integers. And this is what the population would be at any given year. We can actually get rid of this current population column now because we've handled that differently. Now, on the other hand, if you wanted, you could actually do this slightly differently, and you could say instead that I want to take an initial population and a rate, just like before, and this time you get to pick the year. And over here, we'll call this one the current population. But it's going to be the population at the value we give for the year. So again, let's do 1,000 as an initial population. We'll do our rate of 5%. Going to do 0.05 and then convert that column into a percent. So what this is going to do for this current population is it's going to take the initial population, which is an E2 or 3 to its left. It's going to multiply by that 1 plus the growth rate, so 1 plus F2. That would produce what the population would be after a year. But then it would take that population and multiply by 1 plus F2 again to get what the population would be after 2 years. And then it would take that value, multiply by 1 plus F2 again, third time, to get what the population would be after 3 years. So each time I do this, I'm multiplying by an additional 1 plus rate. And so I can actually find out what the current population would be at any year end if I just take this value 1 plus F2 and raise it to the power of whatever year I'm on. So I'm going to raise this to the power G2. Let's put in a year, say year 4. If I do that, this value here should give me 1216, although it probably will give it to me as a decimal, which we'll have to correct by getting rid of those decimal points. If I give it a different year, year 9, it should produce 1551, which it does. And so this is two different ways that you can handle population growth. You can either have an individual field for every year and simply reference the value above it and calculate it 1 year at a time, or you can have a more robust formula that takes the actual year into account and can figure it out at any point. So this is like a function that does what's happening in each of these rows. All right, now let's expand this one more time and take a look at what would happen if we did compounded interest. For compounded interest, what happens is we're still given a rate that's considered an annual rate, but it's going to hit multiple times. So this is like if you had a bank account and you had like a 3% interest rate on that bank account, but they're going to give you interest every month. They don't give you the full 3% interest on the month. They're only going to give you 1/12 of that because that's 12 months in a year. So when you do compounded interest, instead of adding the whole growth rate, you're only going to add the fraction of the growth rate that you get for how many times you're going to compound. So let's modify this in order to work for compounded interest. So what we'll do is it's basically the same idea. It's just instead of a population of people, we're thinking of a population of money. So I'm going to add a column here right in the middle between year and rate. Instead of calling it initial population, this is going to be the initial amount of the investment, which is usually referred to as the principal of the investment. So we'll put principal. The second column will be the rate, and that still means the same thing that I meant before. For this third column, what I'm going to put in is the number of compoundings every year. So this is how many times you're going to receive interest on this investment. For most things, it would be 12 because you're going to get it monthly. So if you're going to have like a bank account, you're going to get interest on that bank account monthly. And so the interest is compounded monthly. So let's go ahead and put 12 compoundings per year in just for now. And then the year is going to mean the same thing, just how long you've had the investment. This time now, the principal, we're going to call this a dollar amount. So let's change this to dollars. And let's say that we invest, let's feel like we're a little bit more rich. We're going to invest $15,000 and at a 5% growth rate, but it's going to be compounded 12 times a year. And we want to know what the value will be at year 9. So now we need to cook up this formula here. Now, if you look up at the formula up here, it's basically the same idea. It's just that instead of multiplying the interest at the end of every year, it's going to happen at the end of every month. But it's not going to add the entire growth rate. It's only going to add 1/12 of the growth rate. So you'll still have the principal here, the E2. It'll still multiply by 1 plus a rate, but we have to modify the rate because the rate is no longer F2. It's actually going to be F2 divided by the number of compoundings. And so to do that, we'll take this rate, the F2, we'll divide it by the number of compoundings, which is G2. And that gives us the amount of percentage that you're going to add each time you compound. But now, in addition, you're not getting this 1 plus rate every time at the end of the year. You're getting it at the end of every month. We're needing to hit it with the 1 plus F2 over G2 12 times for every one of those years. So you take the number of years, but then you have to multiply by how many compoundings it's going to do as well. So that'd be H2 times G2. And so again, this formula takes the principal amount, it multiplies by 1 plus the growth rate, and since the growth rate occurs at a number of compoundings G2 every year, the growth rate is going to be the annual rate divided by how many times you're going to compound. But then you're going to compound that or multiply by that growth rate, that many number of compoundings every year. And so if you want to run it for H2 years, you actually have to compound H2, the number of years, times the number of compounding, because that's how many times the interest actually got hit. And so the exponent becomes H2G2. And if I hit enter now, this is now actually the value of my investment after 9 years. You can change the years if you want. Maybe it's after 15 years. You can see how much that is. You can change the rate now to maybe 3.5%. That's pretty much how compound interest works and how to code it into a spreadsheet. We're going to have a second part to this video here that talks about what's called the compound annual growth rate, or CAGR, C-A-G-R. And what this basically does is it says if you have an investment and you know the beginning and the end, how would you be able to figure out what the kind of average growth rate would be? And basically what you do is you put it into the formula that we just had here and you kind of invert it. And so that's what we're going to do in the next video here based on this idea. But that's it for today, and we'll see you next time on Trigonometries.